Hey guys, my name's Eggs on Toast, and today I just want to build a little snake game using Rust and Macroquad. It's not really scripted, so it is what it's going to be. What it's going to be. You could consider a tutorial. I mean, feel free to follow along, but this is not really premeditated, so I don't really know what the code's going to look like in the end. But yeah, that's what's going on right now. Okay, so let's get into it. The first thing I'm going to do is go into my source projects and make a new project. I'm going to call it Snake Game. Maybe just Snake. Cargo Snake. I'm going to CD into it. I'm also going to need probably Macroquad, because that's what I'm going to use for graphics. Very nice. Okay, let's get building. So the first thing we need is a window, and we can do this quite easily. We just need to use Macroquad, prelude, everything. We need to annotate main with Macroquad main. Give it a title. How about snake? And this macro requires that the main function be declared as async. I'm going to get rid of hello world, create a loop. And inside the loop, we're just going to start out by clearing the background with black. And we're also going to do a next frame dot await. And that's all for our starter code. If we make this a little smaller, open up a terminal, give this a run. It's going to build everything. It's going to build everything. Rust compile times be like. Just a little longer. Almost there. And there we have it. So we have our little Macroquad window. Very nice. So the next thing we need to do is, so our snake game is going to be made up of cells. It's going to be made up of these cells. So what we need to do is we need to decide how big we want our game board to be. So our screen width in cells is going to be an unsigned 32-bit integer, and we're going to start out with like 10 cells. And we also need to configure the screen height in cells. We'll just keep it 10 for now. Now we need to determine the cell size in pixels, because all cells are going to be squares. So cell size in pixels is going to be a float. And we'll just say, I don't know, 20 pixels. We can change this later. And now the screen width in pixels is going to be a float, and it's going to be the screen width in cells as a float times the cell size pixels. And the screen height in pixels is going to be the screen height in cells times the cell size in pixels. So now we're all ready to go. So right now we have a resizable window. If we just open up our terminal, cargo run, we'll notice that this window is fully resizable, which we don't really want since we have constant screen size. So what we need to do is configure that a little bit. The way that we do that in Macroquad is with a function I'll call it window conf, and it returns this special type conf. And this conf is basically like a window configuration. These are all the aspects of the window we can configure. We want to configure the title, width, height, and whether we can resize the window. So the window title is going to be snake. Dot. I'll just do to owned. Why not? The window width is going to be this screen width pixels, and then screen height in pixels. And then whether the window is resizable, we want it to be false. Now, let's see, this expects an I32. Now, I do want the unit for pixels to be float. So the proper type for screen width pixels is float, but we just need to cast it to an I32 here. Because ideally the cell size in pixels should be an integer. So it should work out that it's pixel perfect. But anyway, now we do need to initialize every field, so we can just initialize everything else from the default trait. There we go. Now instead of passing in a string here, we can just pass in the window conf. Whoops. We can just pass in the window conf. Make this a little smaller. So now, if we do a cargo run, we'll have a much smaller window, and actually I just realized maybe I want this to be a bit bigger. So I think I'll bump this to 15. And I'll bump this up, maybe twice as big. There, that's a lot better. Okay. So what we're going to do now is, it would be nice to have a visual aid for the grid. So I'm going to create a function to draw the grid. It's going to draw some grid lines to highlight where the cells start and end. So I'm going to create a function, draw a grid, take no parameters, and return nothing. And the first thing we're going to do is we'll draw the vertical grid lines first. So for x in 0 dot dot screen width cells. Excuse me. For x in 0 dot dot screen width cells, we want to draw one line. There's this function draw line we can use. It takes a starting point and an ending point. Now the x position is going to start out as x. The y position to start out is going to be 0, and then same x. And then we want the new y position to be all the way down at the bottom of the screen, so that's going to be screen height pixels. And then we need a color. Let's do it dark, right? Now this is an error. The error is that, oh yes, so this function also takes a line thickness, which I forgot to supply. We'll just say 1 pixel. And then the error here is that it expects a floating point number, but we gave it an unsigned integer. So we can fix that by just letting x be x as f32 times cell width, cell size pixels. So that's going to magnify our x step to be the pixel size. Now we can do the same thing for y. For y in 0 dot dot screen height cells, we'll do something very similar. We'll start out by letting y equal y as f32 times cell size pixels. And we get an error for some reason. Oh, that's if. We need 4. Great. Now we'll do a draw line. This time we want the x to start at 0, y screen width pixels and Y again, same thickness, and dark gray. And I think just for why not, just for good software practice, I'm going to do const line thickness, f32 equals 1.0, and const line color. It'll be a color, it's dark gray. Very good. And then we'll just do line thickness, line color, same here. So that looks really nice. Now we're just going to draw the grid in our loop. And there we go, there's our grid. It's nice to see where all of our grid cells are. Awesome. Next, what do we do? Well, it'd be nice to have a snake. It'd be nice to have a player. So let's do that. Let's create a new module where we'll keep all of the player-related stuff. Whoops. So I'll type in mod snake. And then I'll create a new file, snake.rs. This is where we'll keep all of our snake-related stuff. Okay. So the snake has some data associated with it, so I'll create a pub struct snake. Now, what data does a snake have? Well, the snake has a body, and that body is a collection of segments, and those segments are basically just two-dimensional positions. So we want maybe the body to be a vec of uvec2. This uvec2 uvec2 is a type from Macroquad. It's just all it is just a vector of two unsigned 32-bit integers, which is just what we need. Just what we need. So this will just be a list of all the body parts. It'll be a list of all the body parts. Okay, it'll be a list of all the body parts. So the next thing we need is a snake. As the snake moves, we need some way to determine which direction in which to move the snake. So the snake also has a direction, current direction. So direction, and I'm actually going to create a new type called direction. It's going to be private. It's going to be an enum, and it's going to have 4 elements: up, down, left, and right. Up, down, left, and right. And this is sort of in an effort to make invalid states unrepresentable. The snake can be going in one of 4 cardinal directions, so we'll model that using a direction enum. Awesome. Cool. So now we need some way to initialize the snake. So I'll just impulse snake here. We'll create a function called init. I don't really want to call it new, because the idea here for me is that we're only going to have one snake, so it makes more sense to have a function called init, because, well, the implication, at least in my mind, is that there's one snake. With new, it's like, okay, you want to make a new snake. There could be many. I'm not really going to explain that anymore because it makes sense to me. But if you're following along, you can call it whatever you want, obviously. It's your code. So we'll make it public so we can call it from the main file. And it's going to return a self. It's going to return a snake. Now, body, we should initialize it to something. Maybe snake will just start out with one body part, one segment. So I'm just going to do vec vec uvec2 new, and we'll just start it in the top left hand corner of the screen, 0, 0. Why not? Okay. Next, the direction will start. We'll start the snake going right. I think that will be okay. Awesome. Now, in main, what we can do is we can create the snake init. It doesn't know what that is, so we can use snake. Use create snake. I know I could omit this, but yeah, why not? Maybe to keep all of my using statements together, I'll move this to the top. Great. So now we're good. We're not using it, but that's okay. We're going to use it in just a second when we draw it. So let's close this for now, and let's create a new function called draw. It's going to take the snake by reference, and essentially what it's going to do is it's just going to loop through the body, so for segment in body, self.body, and this is also going to error because we can't move out of body, so we have to reference it. So for segment in reference self.body. What we're going to do is we're going to draw a rectangle. That's not found because we didn't import the prelude. I'm just going to use Macroquad shapes. Actually, scrap all that. I'll just include the prelude, why not? So now we're going to have access to this. So it takes in an X and a Y. Now the X is going to be it's going to be segment.x, segment.y, .y. And of course, since these represent sort of world space coordinates, we need to convert them into screen space coordinates by doing as f32 times, I guess it would be cell size. Oh, hello. I'm doing something weird outside of my apartment. And by something weird, I think blowing leaves. But anyway, cell size pixels. Oh, that's annoying. Okay, so we don't have access to cell size pixels because it's defined in the main function. Sorry, it's defined in the main file. So how do we deal with that? What's the best way to deal with that? I think just the way that I'm going to solve it for now is I'm just going to create a file, lib.rs. I'm going to move a lot of the I'm going to move some of the stuff into there. So I'm going to move these into there. I'm also going to move this into there, I think. Just makes sense to me. Make these pub. Make this pub. And we'll use raylib prelude star. Sorry. Macroquad. I make a lot of stuff with raylib as well. So okay, cool. So now that we're done with that, let's solve some of these errors. We can go ahead and use snake See here, we have to do snake. Maybe I'll just I'll take the Rust compiler's suggestion for now. Use other snake. It's a little janky, but I'll figure something out. There we go. Okay, cool. So now we want to go in here. So now we'll use crate. Actually, we don't need to do that. We can just come in here and just do crate, just like that. As F32 times crate, cell size, pixels, and then the width and height, crate, cell size, pixels, crate, cell size, pixels, and then I think it wants a color. I'll just do green. We have errors. My opening splits. Also, why can't you tell me what this error is? Oh, I know what's going on, because snake is declared as a mod here. What we want is for it to be a mod here. There we go. That's gonna work out better, I think. Okay, great. Problem solved. Cool. So let's go to main and let's do a snake.drop. Basic snake. Maybe I kind of want to change the name of the project from like snake to like snake game. Just so things won't be as confusing. So that means we're gonna have to use snake game. Just like that. Remove this import. And then use self. No, we just need this. Okay, so that's good. Now this needs to be snake game snake. Personally, I don't like to merge my imports into just like a single use statement. I think it starts to get a little hard to visually parse. The one time that I will use the curly braces is when I'm importing a lot of stuff from one module. So maybe that'll come up. But anyway. Alright. So I think we're good. I'll go run. Yeah, great. There's our there's a little snake right here. Nice. Very nice. So now, a natural next step is to move this snake around. Yeah, okay. So I'll just create a function called, I don't know, we'll just call it move. We have to prefix it with r hash. I think they call that a raw identifier. And the reason we have to do that because move is actually a keyword in Rust. So if we get rid of this, this is going to cause some interesting errors. Expected a name, syntax error, escape move to use as an identifier. So we have to use a raw identifier here. Cool. Now it's going to take self-mutably. Okay. So what do we have to do? Well, we have to inch the snake's body along. Now, a clever trick to do this is we can actually pop a segment from the end of the body and push it onto the front. Now, using a vector, that would look something like block equals self dot body dot pop dot unwrap. So returns an option, and then we would do like a self dot body dot push shift body dot insert one block prime after we sort of do some modifications to the block. Okay. So the only problem is that since body's a vector, inserting at index 0, inserting at the front is really inefficient. It actually has linear time complexity with respect to the length of the vector. So because of that, I think since we want efficient popping from the back and efficient pushing from the front, the right data structure for this is actually std collections vecdec. So instead of using a vec here, I'm actually going to use a vecdec for double-ended queue. Now we could also use like a single-ended queue, theoretically, but Rust doesn't actually have that in the standard library. I think it only has vecdec. So what we can do is we can pop from the back. Actually, first we need to get the head. So let's say head equals self.body.front. So that's the front of the snake. And we'll unwrap since we want to assume that the snake has something in its body. Assume that the snake has something in its body. Now, we want to determine the new position of the head based on the direction in which we're going. So we'll match self.direction. And in the case that we have direction up, we'll create a new uvec2. uvec2 new head. We're going up, so same x direction, head.y -1 -1, yeah, yep. And if I remember correctly, I think uvec2 actually has this handy method .withY, so it'll reuse the x coordinate, and then we can just give it a new y coordinate. We'll fix that in a moment. And then direction down will be head with y, head.y +1. Left, head dot with x this time, head.x -1. And then right, head dot width x head dot x plus 1. That looks good. Now we're going to save this into a variable called new head. And I think I'm actually going to rename this to old head, just to have some symmetry, I guess. Now what we want to do is we want to pop the back of the body. So we want to do like a self dot body dot pop back dot unwrap, and then we'll do a self dot body dot push front dot push front new head. So that looks pretty good, I'd say. Except we need to change this because we're no longer using a vector. We're using a vecdec. We can actually use the from function from the from trait to convert an array into a vecdec. Very, very good. Now, if we go to main, we have to move the snake. So I'll do like a little update section, a little draw section. And we'll do snake.r#move. We have to declare the snake as mutable in order for that to work. So, doing cargo run. And it's actually really fast. The snake is actually really fast. Because we're doing nothing to limit how often this loop is running. So we do have to do that a little bit. Now, I don't really care to limit the drawing code, just the update code. So I'm not gonna lie, I'm a little rusty on doing that kind of thing manually. Usually I work with Raylib and there's a way to manually, or sort of say, limit the frame rate to, say, 20 FPS, and it will just take care of everything automatically. But we're having to do it manually here. So, let me think. What I know Macroquad has is there's this function get frame time, and that's like a delta time, duration in seconds of the last frame drawn. So maybe we say like const target frame time in seconds is going to be target frame time in seconds. We could even make it a duration if we wanted, but that's sort of a little complicated for right now. So target frame time in seconds is going to be it's really like a seconds per frame. So it'll be 1 over frames per second. So maybe 1 over 20-ish. So 1.9 divided by 20. Let's give that a try. Nice. So, what we're gonna do is we're gonna create something like a frame clock. I'll come up with a better name for that in a second. but it'll start out at 0, I guess. Maybe I'll change it to frame timer. It'll start at 0, and then if frame timer if the frame timer is less than or equal to target frame time, what we're going to do is run the update code. And then we're going to do frame timer equals 0. We're going to reset the frame timer. And every frame I don't actually know. I don't actually know. Because the way this is going to run right now is it's actually going to wait a little bit at the beginning of the program, which I guess is fine, but I don't really like it. So let's just try it for right now. And then last frame time. I'll just do like a frame timer plus equals get frame time. And let's see. That does kind of work. Okay, 10 frames per second. Yeah, nice. Okay, cool. So that does work. You know, I'm gonna keep it like this for now. And maybe it'll never ever change ever again. Who knows? Doesn't really matter. This might not be the best way to do it, but does it really matter? Not really. Okay. So good. Okay. So the next thing we want to do is we want to be able to control the snake, because it just moves in one direction, which is a little lame, I think. Just a little bit lame. So yeah. I think what I'm going to do is I might just have a function called update. Mute self. I'm just going to call self.move. And then, like, if I'm going to check if the arrow keys are pressed. So, like, if maybe is key pressed, key code down. Actually, here's what we're going to do. Here's actually a really good thing we can do. We can create a function, impl direction, and we're just going to say from key press, from key code maybe, and it's going to take in a code, maybe even from key. It's going to return self. We'll match key. In fact, maybe even option self, because the key might not really be relevant. So we want to create an association between the keys and the directions. So key code up is going to do some self up, key code down, some self down, key code left, some self left, key code right, some self right, and anything else is going to return none. So that's looking really good. The next thing we're going to do is we're going to do maybe, is there like a key get last key pressed? Okay, that's really exactly what we want. Let key equals get last key pressed. It's going to be an option key code, and here's what we can even do. We can even do a dot and then, and we can map over that with direction from key. That is just so beautiful, don't you think? That is just so beautiful, don't you think? And if let some direction equals that, self.direction equals direction. Isn't that just amazing? Isn't Rust just amazing? Isn't that just beautiful? Maybe I'll even do direction equals VT that there equals direction. So I can split it up a little bit. Yeah, that's good. Yeah, I know these are called the same thing, but do I care? Not at all. That's okay. Doing some monadic programming here. Absolutely love it. And then instead of calling snake.move, we'll just call snake.update. Term, cargo run. And yeah, we'll deal with that panic in a second. What I realized is that we have to process the input outside of the delayed context, because then it'll only be checking for input 10 times a second, right? Or what, 6 times a second? I don't actually know, but not enough. So what we have to do is like snake dot process input, and then do like snake dot r move. We have to define what's going to be sort of a controlled update and what's going to be a constant update. So let's get rid of this. Let's call this process input. And now let's give that a run. And that is looking so much better, because now what we can actually do is press the key anytime we want, and it will capture it. Now the snake goes off the screen if we go to the right or to the down, but if we go to the up, we'll get this error. Thread main, panicked, at source snake.rs, attempt to subtract with overflow. Okay, fine. And I think this is actually not great. I'm running NeoVim inside of NeoVim, which is not really what I want. Sure, I'll update lazy. So that's coming from this. That's coming from this line right here. So we're trying to go up into the wall. Now, we have to decide what's going to happen. We have to decide what we want to happen when the snake hits the wall. I think we maybe just want game over when the snake hits the wall. We maybe just want game over. So I don't really want to solve that problem right now. I kind of want to do the apple next. And actually this video is getting kind of long, so maybe I'll just cut it here and do a second part if this one does well enough. But anyway, I guess I'll just do that. See y'all later. Thanks for watching.